In the last 80 years, computing has effectively transformed most of humanity. We have now superpowers that our ancestors would really not distinguish from magic.
We've been working on a one-stop shop integrated hub for IoT firmware devices.
Like a mix between a $1 million homepage and Decentraland.
Global directory.
A social network.
Peer-to-peer file sharing.
Spreadsheet app for stock market.
Custodial wallet.
A decentralized e-commerce protocol.
Python tooling for the Filecoin network.
I was looking at this more as a way to get familiar with the technology.
I guess I was bored. I wanted to work on something really cool.
An experiment, because you can see how far can we go.
You literally can build a company in 48 hours.
The feeling like you're in the middle of a big movement that's going to replace everything we know currently about how that technology is working.
Computing platforms of today are going to shape the way that humanity operates for many decades to come.
This new world that we want to build, one that is meaningfully decentralized, one where people have open access, but without the trade-off of giving up all of the data to some third party. That can only happen if people build this future.
I mean, it's just mind-blowing, right? Like being part of something that's most likely going to change the world as we know it.
Gather up, everyone. Gather up. We are starting our fireside chats around the campfire. Hello, I'm Angie Lau, editor-in-chief of Forkast.News, and on behalf of our very dear partners at Decrypt, we are thrilled to explore the past, present, and future of Filecoin. Now, IPFS launched 5 years ago. Filecoin raised more than 200 million in the largest token raise of its kind, and the promise is nothing less than storing humanity's most important information. So let's fast forward now to the year 2020. It's been a heck of a year. We're in the fourth quarter and Filecoin mainnet launches. Now, once upon a time, as you saw in that video, just like all of those developers at HackFS expressed, this was really nothing more than a dream. But today, Filecoin miners are close to 1 exabytes worth of storage. We're probably going to see that in the next 48 hours. Now, that is a lot of storage for what we deem to be the most dear to all of us. The idea, of course, is to expand the reach of storage in a truly decentralized and communal fashion so that things like censorship or disappearing data or broken links, limited bandwidth, lack of access are all things in the past, because the future, as we see before us, Web3 is here. So thanks for joining us from around the world, everyone. We see you. You're joining us from across the US, across Europe, and right here in Asia. We picked this time because it crosses truly all time zones. It is a global conversation you're about to engage in right now. And your role in this future is as important as those who will be speaking on the panels today. Now, as many of you might know, on October 15th, Filecoin went live. Now, 1 month later, we are here. What's next? We're going to explore Filecoin past, present, and future, from launch to how it's being utilized and implemented right now to what the future holds for IPFS and Web3, and frankly, all of us who are going to use it. The fate of humanity depends on nothing less. So let's get started right away. The day that launched 1 billion bytes, the Filecoin launch, tokenomics, ecosystem, and more. Moderating is Decrypt co-founder and coding genius, Ryan Babinski.
Hello, everyone. Welcome. Thank you for joining. Very excited to be hosting this first panel of this session. So we'll be taking a look at Filecoin's past, the steps along the way over the past 5 years to get to the mainnet launch just over a month ago, and this incredible milestone of 1 exabyte. So joining us here today, we have Molly McInlay. She's the project lead for IPFS and the Filecoin network. We have Colin Evren. He's the head of ecosystem and operations with Protocol Labs. Ayus Rajasekaran, he's an engineer at Protocol Labs working on Filecoin. and Ian Darrow, in-house counsel for Protocol Labs. So, of course, we're all thinking about the mainnet launch that just happened, but in this panel, we want to zoom out and take a look at how we got here. So the IPFS project itself, the underpinning protocol that enables so much of what the Filecoin network can do, actually launched over 5 years ago. So this is a project very much, many years in the making. And 3 years ago, 2017, Protocol Labs launched one of the largest token fundraising events of the year. And a month ago, we launched. So to kick it off, to hand it over to the panelists that we have here today, I want to first ask the question, well, what is Filecoin? I think when one thinks of storage in the cloud, one thinks of maybe backups for their iPhone, or where their numerous photos that they take on their cell phone disappears to, or perhaps AWS or Azure if you're a developer. But to help us get acquainted, I'd like to ask, how should we think about Filecoin? Basically, how is Filecoin different than these other cloud storage providers?
Sure, I can take this, Ryan, and thanks for having us on. It's a real pleasure to engage with your audience and with Decrypt here. So to step back, Filecoin's mission is to create a decentralized, efficient, and robust foundation for humanity's information. Our community truly believes that humanity's most valuable resource is information. And so we're incredibly passionate about storing and protecting that valuable resource in an efficiently priced and distributed way. Now, for users of storage, this means addressing some of the major problems with today's storage infrastructure. First, decentralizing the cloud away from a small number of centralized providers. Whether you like or hate the large cloud storage players, we truly believe users should have options and choice to store their data beyond just the few that they have today. 2 is giving users full control over their data. Users get to make their own decisions about what happens to the data that you store on the Filecoin network. 3 is turning data storage pricing into an efficient market, allowing the network to set prices rather than corporate pricing departments. And we're proud to say that so far there are substantial price savings to store on Filecoin relative to the large cloud storage players. And 4th, making storage verifiable to ensure that when someone says they're storing your data, they actually are, and removing issues around data integrity or fake news. And so you can think of this whole network as an analogy to like the Airbnb of storage. So instead of just having to pick from a few hotel chains when you travel, you now have a diverse set of options of individuals and businesses that want to compete in unique ways to store your data, different prices, locations, retrieval speeds, certifications, etc. But as an entire global network, data storage providers on Filecoin are able to compete effectively with the scale, reliability, and price efficiency of the larger players.
Right, and so you're talking about, just like with Airbnb or any kind of network, it's really about the options that are available to you. And you did just reach this incredible milestone of, well, we'll say 1 exabyte, but you're on your way to 1 exabyte. Ayush, you're a developer. Can you break it down for us? Just how much storage is that, and what's involved in a rollout of this magnitude?
Yeah, definitely. And thank you again to Decrypt for having us here and for putting this together. It's exciting to be here. So the 1 exabyte and soon to be 1 exabyte number is one that I think we're going to be hearing a lot about because it's a big number and it's an exciting milestone. The way I've kind of been explaining it to, let's say, family and friends, you can sort of think of it both quantitatively and qualitatively. Quantitatively, what I've been saying is that's probably somewhere between 800 to 1,000 times the amount of storage of Netflix's entire library, probably with backups. So that is the amount of storage that's live on the Filecoin network right now, only a few weeks after launch. Somewhat more colorfully, some people enjoyed this analogy, is if you think of your standard 16 terabyte hard drive, and if you had to stack them up in order to store the amount of data that we have on Filecoin right now, I think the height of that stack would be about 2.5 times the height of Dubai's Burj Khalifa, the tallest man-made structure. So that's a somewhat more colorful analogy. But I think, and obviously these are exciting milestones to talk about. From a technical perspective, maybe what's most interesting is that as recently as, let's say a few months ago, I think people were genuinely unsure whether this would be possible or not. And I don't mean naysayers, I don't mean overly pessimistic people. I think there was genuine technical skepticism about whether it's possible to build a decentralized storage network at the scale. I think the ambitious goal that some people were saying would be, something about 1/100th of this size. And we haven't solved all the problems. We're working very hard every day, mostly to reduce the cost, the time and space cost of validating so large a network. But the definitive proof that we have that it's possible is the network that we have right now with 1 exabyte of data on it. I think getting here was a long story. A lot of obviously research development had to happen along the way. A lot of problems had to be solved. Some of them had to be recognized as perhaps impassable for now and needed to be skirted around as opposed to actually solved. But that's kind of where we are today, and we'll see how much more we can do.
Right, but these, I mean, even just 1 month after mainnet launch, these are like mind-blowingly large numbers, like you're saying here.
Yeah.
You said 700 times the basically the storage requirements of Netflix with backups. Could entertain humans for all their history, perhaps. But Molly, I want to turn over to you as as the project lead for IPFS. Could you talk a little bit about what had to be built to get here? As you framed it, basically what had to be invented to make the Filecoin network even possible?
Yeah, so from the first Filecoin white paper back in like the 2014 timescale, we've obviously come a super long way and we've learned a ton, and a huge array of infrastructure and underlying tools have needed to be built in order to make this possible. So I think we've already talked about the alpha launch of IPFS back in 2015, and all of the ecosystem and tools that have been built around that. But frequently, that gets less of the credit is all of the immense work done on multi-formats, IPLD, and libp2p, which are the underlying technologies on which IPFS itself is built. So that's our P2P networking layer and the content addressability and the way that we structure data in such a way that anyone can verify it, and we can make sure that two parties who are serving the same data can access it from the same content address hash. And so those kind of core fundamental primitives that we invented and made available helped amass a really awesome ecosystem of amazing tools and applications throughout the Web3 space, and then formed the foundation of what was needed in order to build Filecoin as a blockchain. In addition, there was a ton of research and development around the proofs of space-time and this is a novel storage system that needed to be created and invented from get-go. So I think there have been multiple different iterations of the Filecoin research paper and spec since then. But now we also see a lot of other blockchains who are utilizing the same underlying components that Filecoin is using. For example, ETH2 is launching with libp2p, Polkadot launched with libp2p earlier this summer. And we see a whole ecosystem of tools that are building on IPFS and utilizing these kind of underlying frameworks in order to help make the Web3 space more interoperable and bring kind of the happy marrying of both content addressability and peer-to-peer networking.
Yeah, you mentioned the composability, right, of these projects, and how very much all of these projects are kind of standing on each other's shoulders to build towards this really incredibly complex, decentralized, distributed system. What's always impressed me about Filecoin is the ecosystem that you've managed to put together from the very beginning, right? This collaboration between open source work, academia, and protocol labs. Colin, as the head of ecosystem at Protocol Labs, I'd like to turn it over to you to talk a little bit about what is that ecosystem composed of? Just what does that even entail? Because there's so many pieces.
Totally. So I'll list a few metrics and then maybe talk about how we got there. So as many folks mentioned, we have over an exabyte of storage on the network across 700 active miners. Over 90 organizations are currently building all sorts of things on the Filecoin network, and there are over 250 new projects entering the space through accelerators and hackathons and the like. And there are almost 5,000 total project contributors that have contributed code on GitHub towards the Filecoin protocol, which is absolutely incredible, right? Now, how do you get there? How do you bootstrap that? Well, it's not easy, and we are just tremendous beneficiaries that the IPFS ecosystem has flourished, like Molly said, for 5 years. And so many of the early applications have come over from the IPFS ecosystem that have been building on IPFS plus Ethereum and now can use Filecoin for persistent storage. And so the list of applications span a whole bunch of different use cases, from consumer storage applications like Slate and Fleek and Audius, to decentralized video apps like File.video and Voodify on LivePeer, to archival storage use cases like Filecoin Discover and Internet Archive and a whole bunch of things like that. We have Web 2 use cases coming in, which are seeing huge benefits on Filecoin, from cost efficiency to verifiability to many other kind of properties. Many of the other blockchains in Web 3 are now using Filecoin as a bridge. So for example, we partnered with Consensus to bridge the Ethereum and Filecoin ecosystems across a number of products, have done the same thing with Polkadot and Ethereum Classic and other things like that. And then a number of groups have started spinning up entry points for new developers to join the ecosystem. HackFS led this month-long hackathon where 130 projects developed, amazing products on Filecoin over the course of that month. Tachyon and Longhash are launching accelerators to coach major Filecoin teams and businesses to be built on the protocol, and ultimately result in demo days where they can raise venture capital and proceed from there. And so it's there's no magic bullet. It's a bunch of lead bullets, and so you have all these ecosystem players contributing in different ways, and the aggregation of all of that gives you what you see today.
Ian, I wanted to give you a chance to chime in here too. As in-house counsel, I'm sure that all of these collaborations and projects that Colin are mentioning gives you plenty to focus on. I'm curious, what was your involvement on maybe the ecosystem side or on the policy side for making the Filecoin network possible?
Wear many hats on the Filecoin project. Historically, I've been involved on the policy side. When it came to launching Filecoin for the sort of 6 months to a year leading up to it, everyone had a shovel in their hand, and that included me. So among other things, one of the things that I worked on that I'm the most proud of was a project called Space Race, which was the Filecoin incentivized testnet. So everything from program architecture to the actual conduct of the competition was something that I had the chance to tackle with a really talented team working alongside me. Basically, Space Race was the way that we bootstrapped the network. So about 6 weeks before the formal launch, we started this competition. And this was the first time that all of the systems and components that make up Filecoin got a chance to be tested at massive scale, with lots of people who weren't working on the project now actually trying to run this stuff on their own computers, and with real incentives at stake. And so we set sort of ambitious targets for the competition. We thought that it would be unbelievably impressive if we got 100 petabytes of storage onto the network within this 3-week competition. And at the end of the competition, we ended up with 230 petabytes, so more than doubled the goals that we had, which we thought were aggressive. Miners in all 6 continents in about 40 countries, hundreds of participants, hundreds of bug reports filed and fixed, hundreds of UX improvements. And then as a wonderful effect of this, the network was able to launch at a pretty significant size. We were able to roll the success of Space Race over into the mainnet launch. And then the network launched, incredibly secure, instead of the sort of like new nascent network that we would have had to, work on very closely to make sure that it was a successful launch. So overall, Space Race was a lot of fun on the ecosystem side. And that's an example of something that I had a hand in.
Yeah, and it's a very clever bootstrapping mechanism, as you said. And I know we only have a couple minutes or maybe 1 minute left. So I wanted to close out with a question that perhaps any of you can answer if something comes to mind. But what do you think are some of the most important lessons that you learned launching the Filecoin network that other projects should take heed? If maybe a rapid fire.
Yeah, I can go first. I think the biggest lesson that I learned personally was that this is an experimental field, that we're doing stuff that has not been done before. We're solving problems that people either have not thought about or have not solved before. And so we should expect things to not work out and expect to run into roadblocks. But at the same time, that the broader Web3 community is really coming together, and therefore there's other people who are interested a bit in these things, even if they haven't already solved it. And examples like libp2p being shared among other projects. There's stuff that we've benefited from as well. Those partnerships, and I think there's a lot of value there that we gained from that we'll continue to gain from, and I think other projects can do so as well.
Yeah, I'll double down on that. Like, there's so many awesome lessons to be learned from everyone within this space. So we benefited a lot from talking really closely with the Polkadot folks, the Near folks, the Ethereum team, understanding, how they set up good governance processes, how they did a phased approach to network launch, the challenges they ran into so that we could, do better ourselves and iterate. And it was really, through standing on the shoulders of these giants that we were able to, have the success we did.
Yep. Fantastic. Well, thank you all. I don't know, Ian, did you have anything else you want to chime in?
I was going to say, if I could carry one message to other projects, it would be, it doesn't work until someone who didn't build it says it works. So that's the last step in testing.
Right. It works on my computer. Sure. Well, thank you all for your time. This was great. I'm really grateful for this opportunity to ask you about, one of my personal favorite projects, of course. But that concludes this panel. And Angie, back to you.
Thank you, Ryan. That was super great. I love the open source nature of this community and the lessons of the launch being shared publicly so that future projects could improve and learn best practices. But now we really want to dive deep. What's exciting for us journalists is what it could mean for the future of media and what it might look like for the 21st century. And it helps us set up for future thinking. Now, Filecoin is described as a decentralized storage network designed to store humanity's most important information. And it really allows users to store, transfer verifiable content address data in a peer-to-peer network. For us journalists who kind of provide and report on some of the world's most important information, we think these are really important technology tools. So I'm going to take off my hat as host and join in on this panel moderated by my very good friend, partner in this Around the Campfire series, Decrypt co-founder and author, journalist, editor, Josh Quittner. Josh?
Thanks, Angie. Hi, everybody. Really thrilled to be here with our friends at Filecoin. And I'm really happy because I get to talk about something that's near and dear to my heart, which is how Web3 technology, specifically Filecoin and IPFS, is going to help journalism. When I started writing about this stuff in the early 1990s, the thinking was that everyone was going to start agreeing because we'd all have access to information. In those days, you really needed access to libraries to find out what mattered and what was going on in the world. And with the advent of the internet, of course, we were able to start sharing information. And so the assumption was that was going to make us all have the same baseline. And as it turned out, as we know right now, nothing could be further from the truth. It's almost like we've built this terrible Tower of Babel, and nobody is speaking the same language, and nobody is agreeing on what's true and what's not. We have a real crisis of confidence. And so I know from our friends at Filecoin that they've been working on things, on methods to help us get at truthiness. And talking with us today will be Pooja Shah, who's a Filecoin product lead, and Molly McInlay again, who's an IPFS project lead and Filecoin network lead, and Paul Chung, who is Director of Journalism and Technology Innovation at the Knight Foundation, which funds a lot of journalism projects. And Pooja, I'd love to start with you. How will IPFS and Vilecoin help improve journalism? I know that you're working on the Starling Project, which is a really wonderful place to start. And I was hoping that you could tell us a little bit about it and how it can help us in the business of collecting true information and presenting it in an easily digestible way to large numbers of people. What's Starling going to do for us, and how will that help us?
Yeah, that's I think a really, really great place to start, especially as we're talking about this topic. So just some context on the Starling project itself. This is a collaboration that began a couple years ago with Stanford University and a group called the Shoah Foundation. And really the aim of the Shoah Foundation is to preserve these extremely valuable archives of human testimony from survivors of genocides, like over the last several decades. So they have this like really incredible archive. It contains more than 55,000 testimonies from genocide survivors all around the world. And this project, they chose to use Filecoin as the storage foundation for their genocide testimony archive because of some of the really unique features that kind of only really exist in Filecoin today. I don't really know of another system in the world that has some of these features embedded so natively. And specifically, like when we talk about these features, we call them verifiable storage features. It's basically this idea that you as a person who is storing data on the Filecoin network, you store your data, the content identifier for that particular piece of data, which is kind of like the unique fingerprint for that content, which is like a fundamental primitive from Ipfs that is also used within Filecoin. That piece of information makes it onto the Filecoin blockchain at a particular moment in time. It's kind of like stamped into the Filecoin blockchain, time stamped into the blockchain. And if someone in the future, say in like 6 months, were to say that they maybe have some like altered version of the data that you originally stored on the network, and they were to claim that that was actually the true original, you could compare kind of the fingerprints of these two pieces of data and see that they actually don't match, and that the later information that's being presented is actually doctored, and that's like actually the misinformation in this case. And all of this is like publicly verifiable. All this information is just like on the public blockchain. And so it's kind of, really, really amazing that we sort of like that this is one of the use cases that I think Filecoin uniquely enables, is just the way that the network, that the protocol is constructed. I think it is a really powerful storage network that just natively can combat misinformation because of the unique features of content addressing and the publicly verifiable nature of storage on the network as well.
So basically facts will be stored immutably and can be cited throughout and any place anyone needs it, academic papers, rags like Decrypt, whatever, it's there, and it becomes something that is unalterable and presumably true unless there's something that disputes it, right? Paul, what do you think about blockchain-based technologies for journalism? You must think about that a lot at night.
In fact, when I first joined Knight 2 years ago, we were doing a lot of interrogation on blockchain technology. At that point, Consensus was really investing in Silvo, which is this sort of like, their consumer-facing journalism project. And I think early on with a lot of blockchain technology, they weren't able to articulate what is the problem they're solving. They tend to be sort of market this as the savior. And also at that point, like the Bitcoin and Ethereum was like at all-time high. So I think it's sort of muddle what the technology can do. And I say right now, when we sort of like interrogate a little bit further of, blockchain-based technology, we really want to ask the question is, how does the technology sort of work in the ecosystem of misinformation and disinformation space, right? So New York Times is working on a project that really focuses on photo authentication and provenance. So I think blockchain could have huge potential in terms of the provenance space. And in terms of storage type technology, one thing that a lot of investigative journalism really grapple with is the issue with subpoenas and all these legal issues, right? So when you sort of do these investigative journalism, like where do you store it? And is Amazon, Google Cloud the safest way for journalism, like the New York Times investigation to put their investigative project? So when we think about, again, in terms of where some of these technologies heading, we're thinking about what is the intersection, right? How do we add a blockchain-based technology to something like a secure jump so that investigative journalists will have that degree of confidence when they know that they're doing something is actually, unhackable, is hard to sort of falsify, at the same time offer certain legal sort of protection. So I think, we see, again, blockchain-based technology to really be more of a B2B sort of player in journalism, but articulate it in a way that's solving part of a giant ecosystem rather than the earlier sort of imagination of, blockchain, as people are pitching me like, oh, we could build a blockchain wallet and people could do tipping to help journalism. I'm just like, well, why are people not just Venmoing or PayPaling, right?
Right.
Is that the best use of blockchain technology? So I think right now, those are the questions that I'm asking at night.
That's great. Yeah, that's really good. Molly, Paul actually raises a very interesting thing, which is that we can now write these effectively citations indelibly on the web. But there are some people that might be a little nervous about that, right? Like journalists have to correct stories, especially now in digital media. We publish and then 20 people say, you idiot, you misspelled that guy's name. And so you quickly go up there and you fix it. But worse, other problems also are things that sometimes people have, there's a right to forget almost, right? So how will we deal with this going forward? How will we correct things? And how will we kind of let some things just sort of degrade into the background?
Yeah, so I totally resonate with some of the stuff that Paul's talking about, like finding the opportunity for the technology to contribute to a really critical part, and this point of provenance and kind of the public record and being able to accurately pinpoint the data that you're bringing in. This kind of talks to Pooja's points as well around Starling. We've actually seen folks use IPFS in that way. So EDGI, the Environmental Data Governance Initiative, did put a ton of data on IPFS in addition to a number of other places to help preserve it into the future and make sure that this public record of how the climate data that we wanted to reference in future court cases, maybe 10 years in the future, wasn't on a single person's cloud or only being preserved by the people who were the plaintiffs in the case, and then the people wouldn't be able to point to accurate information about the climate impacts that they felt at the time. And so there's definitely an angle here of the content addressability and being able to accurately look at a version history of information is actually really critical for a lot of the public discourse that we're seeing. But yes, of course, you want mutability as well. You want to be able to go and correct mistakes as you make them. And so there are very much those mutable layers on top of an immutable foundation, such that you can see the version history, but you can direct people to the most up-to-date version. We see the latest Wikipedia page when we look at it. We don't look at every single edit on our way to that final page. And so just similarly to that, many of the applications that build on top of IPFS can use that versioned history in order to make sure that anyone can see that change in time, but that at the end of the day, it's not truly a permanent web. That was an early moniker that we used for IPFS that had some kind of bad misconceptions around it. Anyone can choose to take content off of the web, stop providing. You as a node operator, as someone operating within the IPFS network, have that agency. It's more about the technology itself and what it enables for having a verifiable history of data.
So as the content creator, then we get to basically control access. We get to fix, we get to correct, we get to store for as long as we'd like, but it isn't like we're somehow relinquishing control to the decentralized web itself. Is that right?
And you're not like, you don't have to store other people's content. That verifiable history is there, and say a public official couldn't go and pretend that the history of all of their past actions and all of the things that they have said in public didn't exist. They can't go back and erase that verifiable version history. However, individuals within the network have the agency to figure out what is the latest, what is the appropriate version of something to point to that is our current understanding of what's accurate.
Josh, it's kind of like I think back to the how in the olden days, I used to do things as an investigative reporter. I'd have to, original source. I would meticulously write in remember those reporter notepads, which people probably are using their iPhones to record interviews right now. But we would have these reporter notepads that I would write furiously. I'd have like one of those pretty bad legal, brown boxes, and then pile my entire research and stories and tapes and files into this. And then it would be the equivalent of putting it in my attic. And then, where does that go? In that same way, I feel like the internet right now is almost at that stage where we could put it on a hard drive. It could be on cloud, but at some point, the amount of data that we're just generating as humans on the internet, where does that go? And then you have that hardware problem. Well, that hard drive is going to, disintegrate at some point. What if there's a fire that you don't get access to it? And so, as a journalist, I think about, how can we use these tools to simply permanently put somewhere that we can access easily at any time. And to Molly's point, and to your point, we're always going to be the most accurate prism and filter to all of that information. If we were to look at all of the library books and the fax, remember faxes, and the photocopies, et cetera, and we filter it to modern day, whoever's in the future should have just all that access. And then hopefully that person whose role it is that they are responsible for and that they know that they need to preserve as a journalist in the 22nd century, for example, that at least they would have that access, right?
I mean, you can almost imagine a time in the very near future when, if we don't have to worry about storage, when we record interviews, you just upload the interview. I mean, you're still doing a service by processing the interview, interpreting the interview, slapping a point of view on the interview. That's what journalists do. But the raw material, if the raw material is there and easily cited, I think that's going to go a really long way to maybe quelling the Tower of Babel. Anyway,
I would say,
thank you. Yeah, I'm sorry. Go ahead, Paul.
The one thing I would add is, because there are so much information itself is neutral. There's neither good or bad, right? But as we face, especially in the U.S. with this, with this election cycle, there's a lot of bad information out there. So I think the question is, knowing that information could be stored limitless, and with the power of AI, where does blockchain technology come in a way that will provide a more pristine sort of machine training data model, right? So if we were to train, if we were to use, the paper record for your local community, they call it paper record for a reason, right? So how do we differentiate that data away from everyone else's data? How do we basically differentiate the clean data from the dirty data? And then when we think about, the future, sort of like the future of journalism, as journalism sort of we track because of resources and other business issue, how do we retain that knowledge base is a question that a lot of news organizations are not necessarily thinking about, right? You might have this whole trove of data, but is actually just sitting there. And is it even the right data for them to retain so that they could pass on that knowledge from, one, beat reporter to another beat reporter? So I think that's a question I would challenge sort of this community to think about, right? Like, don't think about just storing the information, but like, how are you storing it in a way that will help knowledge transfer and knowledge, advance the right kind of knowledge, so that we don't have the state that we have now, which is really, every truth is contested.
Yeah. I could talk about this for at least another 3 hours tonight, but I think we're well out of time, and it's time to go back to Angie, who's going to be talking to Juan. Thank you all so much for this. It was really energizing and as well as enlightening.
I agree with Josh. We could have talked forever on this. These are critical issues, but now for our main event, we have been huddled around this campfire now, and we're ready for our fireside chat. So you've got your marshmallows and your s'mores ready to go. He is one of the most prolific minds in blockchain today. Juan Benet founded Protocol Labs in May 2014, went through Y Combinator in the summer of 2014 to support development of IPFS, Filecoin, and other projects. Since the launch of IPFS, he has developed other protocols at Protocol Labs. And joining now in this candid and intimate fireside chat around the campfire is Juan Benet, Protocol Labs CEO. Juan, it's great to be here with you.
Thank you so much. Thanks for having me. It's been fantastic to just hear the conversations today. So really excited.
Let's pick it up right from where the journalists left off. You know, these are tools that you're really building out for Web 3.0. Help us all understand what the potential of that future is. What is Web 3.0?
Yeah, it's a great question. So the key thing that's happening right now with a lot of the blockchain technology that's coming out and other systems like IPFS and so on, is that we're adding verifiability into the technology, into all kinds of parts of our computing infrastructure, so that we can trust systems more, right? So when you make a transaction verifiable, when you yourself with your computer can check that that transaction actually happened correctly, and you don't have to just take it on faith or on trust of some other organization, you gain a significant level of confidence and trust in the system, because you know through math you can prove that transaction happened correctly. And that technique is being extended to all kinds of things, from how we store things to how we distribute things, to being able to verifiably keep records in the long term, or being able to verifiably construct good and better markets. So there's a whole bunch of very interesting techniques that are coming from cryptography or game theory, distributed systems, that together are adding up to kind of sprinkle verifiability across all of our computing infrastructure. And so that's the transition that's happening. And one of the big pieces here is that in order to add verifiability all over the stack, you have to build pretty large and significant and complex systems to kind of move over, right? So when you think of something like Bitcoin or Ethereum, just to add verifiability to transactions or to smart contracts required the invention of a totally new platform for moving around value, and created a whole different kind of world. And so now this world is getting integrated with the rest of our computing infrastructure. And so that's kind of the transition that we've been describing as going from Web 2 to Web 3. When we take some of these applications, we add verifiability, we start using some of the primitives of this new technology. We now are building kind of Web 3.0 applications. It's kind of similar to the Web 2 transition. In the Web 2 transition, we moved from static websites into dynamic websites that had user that became read-write, right? So I tend to think about this as Web 1.0 was just you were able to read information on the network. Web 2 added read-write, so you now are able to kind of read-write, and you had the explosion of social media and all these dynamic kind of systems and things like markets and systems like Airbnb and whatnot. And now we're adding trust, so read-write trust, and that comes from the verifiability in the network.
I mean, we thought we had trust in Web 2.0, but I think we've all very quickly realized that, in the noise, in the babble, as Josh put it, it's anything but. Now, remember, audience, this is the first time that we have Juan Benet live post Filecoin mainnet launch. This is your opportunity. It's an exclusive opportunity. We're thrilled that you've joined us. And Juan Benet, the questions are coming. So just to pick up on that point of just the verifiability, the trust factor. We have a question from the audience, and she writes, considering that millions of people consume news on social platforms that operate on business models that are not only antithetical to IPFS, but actively profit from mis or disinformation, what is your roadmap for bridging this gap of knowledge to the average consumer? It's a great question.
So, and this is a roadmap for the broader industry, right? We are one group and one party, and one set of projects in the space. The way that we think about this is that what we've seen lately with misinformation and disinformation on the web and through our many platforms is really alarming, right? So we're dealing with a challenge to humanity on a pretty major scale. The ability to manipulate large groups of people to think one thing that's not true is really unprecedented. We haven't seen this level of information manipulation ever before. Now, there are historical precedents for things like this. Like when radio first came out, you had a similar kind of shift in media and the control and use of media. And one of the most successful users of radio was a whole bunch of different political movements that started understanding how to use this new direct access medium to talk from kind of like heads of state directly to the people. And so you had on one side kind of like the famous Fireside Chats from the New Deal era, and on the other side you had also fascist groups and so on being able to move around a lot of propaganda. So the creation of a new medium brings all kinds of different challenges with how information flows and how different parties are able to use it. Now, as people got used to radio and people got used to this new flow of information, all kinds of systems developed to better be able to deal with that information dissemination. So what is happening now on the web and on the internet, and what needs to happen more, is that we need to form, we need to use both technology and human networks of people doing work together to distinguish what is true from what's not true, and what is likely to happen and what is not likely to happen. So this is, in one part, it's a lot of important technical components. So things like provenance, like we're discussing the ability to record the provenance of information, be able to commit to a public record that is not going to go away. That is, there's like an indelible version history of any kind of a very important public event, so that our democracy can actually rely on that historical evidence. And at the same time, we need to be able to put that provenance and the information of that provenance directly in the user interfaces of humans interacting with that information, so that where that, if you see a picture, imagine your computer being able to tell you the provenance of that image, whether or not that has been doctored, whether or not that's a real image. With the rise of things like deepfakes and all that kind of stuff, that's going to get more important. And then lastly, I think it's a human-oriented network thing, where you need systems of humans distilling what is true from not true, what is likely to happen from what's not likely to happen. And we need to find better organizational structures for achieving that. And that's a human systems problem that I think remains open. I think we have a lot of really good suggestions, but nothing yet has fully worked. But I hope that it'll get solved in the next 5 to 10 years.
It's so true. Technology is only as good as the people who use it. It is a tool, but we're in the driver's seat right now. I mean, you make a really good point about video. Video, though, it consumes a lot of data. Video, as many of us has probably experienced, when we are running out of data plans and our Wi-Fi is bad, it streams less well. But you're close to 1 exabyte. That's, I understand it's a lot of Netflix videos. But how does increasing storage power allow for new innovations and developments that weren't previously possible for IPFS? Yeah.
So in the kind of the Web3 wave of technology, started with systems like Bitcoin and Ethereum, which presented transactional structures that kind of scale to a certain point, right? Very good for a certain size and scale, but definitely not good enough to host whole applications, right? So you can maybe use something like Ethereum to power the business logic of an application, but you cannot store, say, an entire chat room or a set of private messages or your personal data and your personal information on Ethereum. You might do it with a system in conjunction with Ethereum, but that's kind of what IPFS and Filecoin are for. Now, what Filecoin allows you to do is to really build full applications that end-to-end store that information verifiably. So you can think of now being able to build things like social networks or things like video distribution systems in Web3 technology directly and only, where you don't have to back things up separately to kind of the traditional cloud systems. So it's one really big improvement. And so that kind of ability, that scale thing, like really being able to reach a scale to compete with and contend with the traditional cloud is something that many people said was impossible. When we first set out to do this, so many people kind of like laughed at us and laughed at me directly, saying, "Oh, you'll never get a decentralized network to like exceed a few petabytes, maybe like 10 petabytes." And now we're passing 1 exabyte. We passed 1 exabyte. We're about past 1 exabyte, and that's a 3 orders of magnitude more, 1,000 times, 100 times more than what people said was impossible. And this is just the beginning of the network. Like we're just a few weeks into the history of Filecoin in terms of the public network. So that kind of scale enables you to compete with the real with like the really massive cloud storage providers that have been accumulating scale for a long time, right? So as a good example, I believe it was like Dropbox was around an exabyte of size at its IPO, and that was after many years of accumulating data. So the scale here that we're talking about is capable of actually taking on the large scale clouds. Of course, it'll take a while to go from kind of amassing the capacity to now turning towards the users and the clients and all of the applications that are going to be built with this new technology. So that's kind of like the next frontier for us. The project is approaching this in terms of phases. Phase 1 is set up the network. Phase 2 is kind of amass the capacity. Now that we have the capacity, phase 3 is go out and get the storage and the large scale usage and start moving lots of applications over to this network. Kind of beyond that, we start looking into the frontier of new kinds of use cases and new kinds of applications that people haven't built before.
Okay, I want to get into the frontier thinking. Go west, young people, go west. And that's where you built up Protocol Labs on the west coast of the US. And now you've circumvented the globe. The miners, open source, the developers, they're all on board. They are building. I love that example that you shared with Dropbox. Took them 5 years for 1 exabyte. Took you a couple of months. With Space Race, it seems really enormously fast. So now we're in the frontier thinking. What is capable? I mean, you're the technologist, you're the computer scientist, you are building the architecture, the infrastructure that will support the future. What kind of cool things does the future hold for projects?
So there's one range of things will be taking kind of existing applications and existing use cases and building them in kind of a Web3 native way, right? So think of traditional social media type applications or video platforms, things of the sort of like Vimeo or things like YouTube and so on, and there's a whole host of systems like this, or live streaming, so things like Twitch and similar kind of environments, and moving those types of applications to work in a Web3 native way. So that's one kind of track in the frontier is translating a lot of those applications. A whole other track is what becomes possible in this new world of Web3, where you have a whole bunch of different primitives to use, like the ability to create and use markets, the ability to have as smart contracts coupled with these systems. That I'm most excited about a whole bunch of potential applications in these directions, where we don't. It is very hard to predict what people will build, but you can see some of these primitives that have never been, as usable before, suddenly being able to be, at developers' fingertips and being able to be weaved into new kinds of use cases. So imagine systems and programs that can hire storage on their own and on behalf of users, something that hasn't really been possible before.
Yeah, it really changes the business logic for a lot of people. Hey, the questions are coming fast and furious. The audience wants to know this one from someone here concerned about the environment. Okay, so could you speak, Juan, to the environmental concerns of storing this amount of data immutably? It's a good question.
Yeah, it's a good question. So, you know, the data is immutably referenced, but what is stored is again subject to market considerations, meaning data will be stored as long as people continue paying for it. So if something is not valuable to store long term, if nobody wants it around, then it'll fade out and be kind of garbage collected over time. And so that's kind of similar to how most other things work. The environmental concerns here, you know, are not very deep relative to other kinds of computing infrastructure and computing systems, right? So as an example of this, think of the proof of work usage on a network like Bitcoin versus a network like Filecoin. In Bitcoin, you have just a very large network consuming a vast amount of energy and resources to power the consensus of the Bitcoin network. And in Filecoin's case, we use a tiny fraction of that kind of energy, and we do something useful with the computation. We actually store valuable data, and you're able to kind of prove that that data continues to be around in the consensus. And that's kind of you know, so if the consensus requirements of something like Bitcoin moved on to something like Filecoin, that would be a massive win, kind of environmentally. The other thought is, hey, humanity generates a vast amount of data, and we'll continue to grow this exponentially. And so the data that we store will also continue growing exponentially. And it is up to us to find ongoing better systems for storing this data long term. And when you start reaching into really long term modes of data storage and to the many decades, there are a lot of different kinds of storage media that are highly compressible in very cheap ways. So for example, there are like crystal systems where you can record vast amounts of data into crystals. It's very expensive to read and write, but you can do something like that. So I imagine in a long-term future, the Filecoin network will likely evolve into being able to use those kinds of storage media. And it's going to be up to the community to kind of decide if, like, you know, we want to head in that direction or not. If the moment that it becomes really expensive to maintain one type of storage media, we'll move on to others. And so in terms of environmental concerns, it's really about an efficient use of that energy and that information. And so Filecoin is vastly more efficient than other systems like Bitcoin, and so on.
Got it. Okay, one more question from the audience. We're almost out of time, but I got to squeeze this one in. The Airbnb analogy is great. Can I ask, how do you plan to monetize the platform and create value for the token?
So we think more around the value of the network in the long term, in terms of the utility of the network for the whole system. So when you think about Filecoin, and there's a whole report, by the way, on this that you can go and read, which describes the model of the Filecoin economy. And you can think of it think of it kind of like a nation, where there's like a group of organizations that all work together with a common currency, and that's Filecoin. And they're all working together to produce something, and that something is cloud storage. And so that community and that nation is exporting cloud storage to the rest of the world. And the better able that community is to produce that good, and kind of, you know, basically sell that to the rest of the world and kind of export out that cloud storage, and the stronger the economy of that whole system is going to be, and the more valuable that community's output and that community's currency and that community's systems will be. So that's kind of the financial structure and the financial economy of Filecoin is modeled after these kinds of export nations.
Juan, I got to squeeze this one last in, and I'm going to ask your permission to extend it just a little bit. I know that your time is valuable, but I got to squeeze this in from the audience. This is a good one. The democratization of technology often has unintentional consequences. What are some of the negative consequences with blockchain, and what intervention point do you think about and what you're setting up now to prevent something like how social media proliferates disinformation?
This is a phenomenal question. And so, I think this is one of the, personally, this is why I and a number of other people working on systems like Ipfs and Filecoin continue to work on them and continue to think ahead. I'm personally very, very worried about the trajectory of technology and where things are headed in the larger scale in the longer term. I think it's extremely important to bake in good human rights into the computing infrastructure and not just take it on faith or on trust in our government systems. I think we have the ability and capability of building a computing infrastructure that establishes a very high bar of operation and makes certain kinds of things verifiable. And if we move, if we can upgrade our computing infrastructure to verifiably provide certain kinds of rights to its users, the world will be a dramatically better place, because certain kinds of really bad abuses will be prevented. So, right? So I think if people are worried about kind of like the short-term consequences of things like the disinformation in social media and so on, just imagine if a state was able to completely 100% control what your computer did, and to 100% get access to all of the information that your computer is able to collect about you. So imagine your phone, your laptop, everything. Imagine if there was like a malicious government out there that was able to, with the computing infrastructure, know exactly what every single citizen is doing at every single moment. That kind of world is antithetical to democracy, and you can't have a healthy democracy in that environment. So I think it's extremely critical that we have a kind of a period of time in history, probably around 5 to 15 years, where we're able to lock in rights into our computing infrastructure. And if we don't do that in this time period, things are gonna be bad. So the message is really loudly saying, make sure that the computing of the infrastructure of the future has your best interest in mind and your rights established, and kind of really fight for those by using and building these kinds of systems.
And I think, Juan, this is why we live in such incredible times, the best of times and the worst of times. But you can't know happiness unless you have experienced sadness. You can't know what is best for our future society if you don't experience some of the worst of it right now. And, these two moments are intersecting in time, because it's scientists and computer developers and, thinkers and dreamers like yourselves and everybody in our audience and everybody on our panel today to think about what should be our future, what should be right in the context of today, so that we could avoid some of the potholes that we're all experiencing today. Well, then we will have done our jobs. Juan, thank you so much for that. Thank you, everyone, for gathering around the campfire. I hope it kept you warm. I hope it warmed your heart. I hope it stoked and kindled some intellectual fire and some inspiration. Now, it was one of the most watched and anticipated mainnet launches this year, from the developers to the miners to also you and me. There is now a new tool in the toolkit for all of us to ensure the information of today gets passed on to the generations of tomorrow. So thank you to all of you from around the world, from right here where I sit in Asia, across the UK, and around the United States. Have a great day. Have a great evening. Thank you, everyone, for joining us around the campfire. Stay tuned for the next one. Until the next time.